All right, in this video, we are going to continue the laws of logarithms. In the previous video, we went over all the log rules briefly. And in this video, we're gonna actually do some expanding and condensing of logarithms because that's what the first quiz is about. So I'm going to go ahead and I'm going to scroll down to an example in the lesson. And then we are going to do this example. So the first example, I want you to write this down in your notes. It says expand natural log of x squared y to the third over 6. Expand natural log x squared y to the third over 6. So I'm just giving you a second to write it down in your notes while I erase this so I have some space to write. I don't need to have my log rules right there because I have it next to me on my paper, just like you guys should have it next to you in your notes. All right, so let's get started. So expanding, what does that mean? What does it mean to expand? Expand means write with as many logs or natural logs as possible. Basically make it as long as possible, as unsimplified as possible. So I look at my input and I want to see how many bases of my input I have. So I notice that I have a base here, an x squared. I notice that I have a base here, y to the third, and I notice that I have a base down here, a 6. So I have 3 bases in my input. That means that I'm going to have 3 natural logs in my expanded version. So what I'm gonna do is I'm gonna start with the top. I notice that these two are being multiplied together. X squared and y to the third are being multiplied. I look at my log rules. The first rule says if you have 2 things being multiplied in a log, you can give them their own log if you add them together. So let's do that. So natural log of x squared plus natural log of y to the third. So that's gonna be my numerator. So I wanna just recap. We don't have a base of our natural log. Our base here, we don't have a base, right? And since it's a natural log, that tells me my base must be e. I just wanna refresh your memories that if there is no base written in a natural log, the base is e, okay? If there's no base written in a log, the base is 10. Anyway, so I just wanted to make sure you guys remembered that. I only wanted to erase that and that. Okay, cool. So now I notice that it's being divided by 6. So I look at my rules and I say, okay, if I have 2 things being divided in my input, then I can give them their own log or natural log with a subtraction. So all I'm gonna do is I'm gonna tack on at the end minus natural log 6. So now I've given each base their own natural log. I've given each item there their own natural log. And you're probably thinking, wow, this is expanded as much as possible. Not yet, because we still notice that we have some exponents in there. And we can go to log rule number 3, the third one, that says if you have an exponent of an input, it can come down in front. So that's exactly what I'm going to do. I'm going to take the exponent of this input and bring it down in front of its log, okay, or its natural log. They're the same, they're kind of interchangeable. So sorry if I'm saying log or natural log simultaneously or interchangeably. Okay, then I look at my natural log of y to the third. My y has an exponent, so that can come down in front of its natural log. This 6 doesn't have an exponent, so there's nothing I can do there. So let's go ahead and write this out. 2 times natural log of x plus 3 times natural log of y minus natural log of 6. There's no more exponents left over. There's no multiplication or division in the inputs. This is as expanded as possible. So that is an example of expanding a log or a natural log. And with expanding, you're going to be utilizing these 3 rules, the first 3 rules. All right? So now I want you to scroll down, and now we are going to do an example of condensing a log or a natural log. So let's find one that I want to do. All right, let's do this one. So I want you to write this down in your notes, this example right here. I want you to write that down in your notes while I erase to make room. Condense 2 times log base 3 of x plus log base 3 of x plus 1. So there is one really, really important thing in condensing, and I'm gonna write this right up here. You can only condense if the bases are the same. You can only condense if the bases are the same. So what do I mean by that? You can only condense if the bases are the same. Well, look at the bases of the logs that you're trying to condense. I have 2 log base 3 of x plus log base 3 of x plus 1. Because those bases are the same, I can condense those 2 logs. If those bases are different, you simply say cannot condense, because the bases have to be the same in order to be able to condense. All right, now that we got that out of the way, what in the crap does it mean to condense? Condensing means write with as few logs as possible. That's what condense means. If you can write this expression with only 1 log, you're solid. Okay, say you had a bigger expression and they had different bases, you just want to combine the ones with the similar bases, which means write with as few logs as possible. So with this, first thing I checked, are the bases the same? 1, are bases the same? That's the first thing I always check when condensing. Yes, I can condense, okay? Then we're just basically gonna work backwards from the expanding logs lesson. Expanding logs, we did exponents last. Well, in condensing, we're gonna do exponents first. Are there any exponents that need to be put back up into the input? So I do notice, and let's use a different color. Let's use light blue. I do notice that there's a 2 in front of the log here, and based on there's a 2 in front of the log. Based on my rule number 3, if there's a 2 in front, then I can bring that back up to be the exponent. So I can move this way, and I can also move backwards this way, okay? Condensing is moving backwards this way. That's condensing. So I'm gonna bring that 2 back up to be that exponent there. This second log doesn't have a number out front, so there isn't anything to bring back up. So when I've done that, I end up with log base 3 of x squared, because that 2 comes back up, plus log base 3 of x plus 1. So I did my exponents. Now I can move on to the next step. The next step is, well, what's the operation between my logs? The operation is addition. So I look at my log rules and I say, which log rule involves addition? Aha. So addition says you can combine these logs and make the inputs multiplying each other. Okay? So addition tells me I can combine these logs with the inputs multiplying each other. So I'm going to use the addition rule, which in our list is rule number 1. Okay, and I'm gonna combine these. Let me do it in black. I'm gonna combine these. The base is the same, so it remains the same. And now I just bring both of those inputs into the same input. X squared times x plus 1. X squared times x plus 1. Because it was adding, I take each input and I multiply it together. Now your answer might be like that on the multiple choice, but your answer might also want you to take it a step further, and it might want you to distribute that, and if it does, it ends up being x to the 3rd plus x squared, because I would distribute that in. Okay, so depending on your multiple choice, it could be either of these. If it's a question where you have to type in the answer, I would accept either of those. So that's an example of condensing logs and natural logs. I hope this helped you with the lesson. If you have any questions, go ahead and send me a message. Hope you guys are having a great day.